engines. In 1994, across the American highway system, a very specific sound began to disappear.
For over 50 years, the high-revving howl of a two-stroke Detroit diesel had been the undisputed voice of American freight. But inside Detroit Diesel's Redford assembly plant, the legendary Screaming Jimmy was being quietly phased out of the commercial truck market. The numbers were absolute. After millions of Series 71 and 92 engines had been cast, machined, and trusted by fleets coast to coast, new EPA emission standards rewrote the math of American trucking. A design that fundamentally required burning oil to survive could no longer be made legal. The company, now under the ownership of a prominent business leader, had to fundamentally change its mechanical identity, shifting production to a specific engine model. Just truck drivers lost an engine that could be heard 3 gears away. Mechanics lost a block that could be rebuilt on the side of a dirt road. The paradox was brutal. The two-stroke Detroit did not fail because it was weak. It was exiled because its defining durability no longer fit the law. But the story of the two-stroke Detroit diesel is not just about an emissions rule. It is the story of how the American highway traded Every week we tell the stories of American engines, factories, machines, and industrial names that once taught the country what power sounded like.
And what happened when the market moved on? Subscribe if that history matters to you. The story begins not with nostalgia, but with a specific place, in Detroit in 1938.
In the middle of the 1930s, the American trucking industry was running into a physical wall.
The country was expanding, freight routes were stretching across state lines, and fleet owners were demanding more power to move heavier loads. But the internal combustion engine, a machine that turns fuel, heat, or another energy source into mechanical motion, was divided into two flawed extremes. On one side was the gasoline engine, an engine that usually uses spark ignition to burn a gasoline-air mixture. It was lightweight, cheap to build, and relatively easy to start in a cold Midwestern winter. But gasoline engines lacked the pulling power needed for heavy freight, and under the relentless strain of moving tons of cargo, they simply did not last.
Fleet maintenance shops were constantly rebuilding gasoline blocks that had burned themselves out on mountain grades.
On the other side was the diesel engine, an engine that ignites fuel by compressing air until it becomes hot enough to burn diesel fuel.
It was practically indestructible. It made massive torque, which is the twisting force often felt as the pulling strength of an engine.
It was highly efficient. But early American diesels were industrial leviathans, built for ships, stationary power plants, and these early diesels were slow-turning iron beasts that often weighed 40 or even 50 pounds for every single horsepower they produced. If a truck manufacturer tried to bolt a traditional marine or stationary diesel into a highway chassis, the engine was so heavy. America did not lack power. It lacked power that could be packaged into a moving commercial vehicle.
Inside a major automotive corporation, a renowned head of research understood this absence in the market.
Kettering saw that if diesel power could be miniaturized without losing its inherent durability, it would completely rewrite the economics of American heavy industry. On the other side was the diesel engine, an engine that ignites fuel by compressing air until it becomes hot enough to burn diesel fuel. The mandate for the engineers inside the Redford plant was brutally simple. Build a diesel engine that was light enough for a truck? Their answer was a radical departure from traditional heavy-duty design. Instead of building a conventional four-stroke engine,
the engineers in Detroit bet the future of the division on the two-stroke engine.
A two-stroke engine, an engine that completes a power cycle in 2 piston strokes, often making high power for its size but with emissions and oiling trade-offs. Fires every time the piston reaches the top of the cylinder. By eliminating the dedicated intake and exhaust strokes, a two-stroke diesel theoretically doubles the amount. The engine could be made smaller, lighter, and more responsive. But a two-stroke diesel cannot pull air into its own cylinders naturally.
To solve this, GM engineers mounted a Roots-type blower directly to the side of the engine block. This was a form of supercharger, a mechanically driven device that forces more air into the engine.
The blower constantly shoved pressurized air into the cylinders, scavenging the exhaust gases out through the cylinder head and packing the block with.
The result of this engineering gamble launched in 1938. It was called the Series 71.
The name was not a marketing invention, it was a physical measurement. The 71 stood for exactly 71 cubic inches of displacement per cylinder. Displacement, the total volume swept by the pistons inside the cylinders, dictated the engine's breathing capacity. But the true genius of the Series 71 was not just its two-stroke operation. It was how the engine was manufactured. General Motors designed the Series 71 as a modular building block. The pistons, connecting rods, cylinder liners, valves. If a customer bought a 3-cylinder version known as the 371, it used the exact same internal parts as the 4-cylinder 471. The inline 6-cylinder 671 launched with a rating of roughly 160 horsepower, a measurement of how quickly an engine can do work. But it weighed a fraction of what older diesels weighed. This modularity was a revolution for the American service network. A mechanic working in a rural farm equipment shed, a machine shop in Ohio, or a parts counter in a Midwest trucking terminal did not. If a mechanic knew how to rebuild one cylinder of a Detroit 71, they knew how to rebuild the entire catalog. Part suppliers only had to stock one type of piston, one type of ring, and one type of bearing to service fleets ranging from small delivery trucks to heavy construction equipment.
The Series 71 was technically brilliant, but it might have taken a decade to slowly convince a skeptical civilian market.
Instead, history intervened. Just as the Redford assembly line was hitting its stride, the United States entered World War II. The military needed massive amounts of reliable, compact power, and they needed it immediately.
The GM diesel division shifted entirely to war production. The 671 became the mechanical backbone of the Allied effort.
It powered tanks like the Sherman M4A2, which used two 671 engines bolted together.
It powered heavy generators that lit up forward operating bases. Most famously, it was the engine that powered the LCVP Higgins boats, the landing craft that delivered American soldiers to the beaches of Normandy and the islands of the Pacific. Through the brutal proving ground of global war, hundreds of thousands of young American mechanics, drivers, and sailors learned exactly how a two-stroke Detroit operated. They learned its strange, high-revving sound. They learned how to adjust its valves. They learned that it could take immense abuse. When the war ended in 1945, those mechanics and drivers came home. They returned to American farms, construction sites, rail yards, and highway fleets.
The Redford plant retooled for civilian production, churning out Series 71 blocks for a nation that was about to embark on the engineering was proven. The service network of human knowledge was already in place across the country. The block was ready. America still had to decide what kind of power it wanted for its post-war highways.
When the wartime assembly line stopped in 1945, General Motors had to convince civilian America that a two-stroke diesel was not...
The breakthrough did not happen overnight in heavy trucks. It happened first where reliability was judged by strict passenger schedules, the American Intercity bus. By the late 1940s and early 1950s, Greyhound Lines was looking for a power plant that could move a heavy coach across the vast stretches of the American West.
They chose the Detroit Diesel 671. When Greyhound introduced the PD 4104 highway coach,
the engine was mounted in the rear, pushing millions of Americans from Chicago to Los Angeles. Fleet owners watched closely. If a 671 could run 1,000,000 miles under a Greyhound bus with predictable maintenance, it could pull a loaded commercial freight trailer.
But to understand why the engine dominated, one must understand how it received its fuel.
Most early diesel engines relied on a central fuel pump that sent high-pressure fuel through long steel lines to individual nozzles. Under extreme pressure, those steel lines could expand, pulse, or crack, changing the engine's timing and reducing power.
General Motors eliminated those lines by inventing a system centered on the unit injector.
Fuel injection, a system that sprays fuel into the engine more precisely than a carburetor, was not new. But a unit injector, a fuel injection design that combines the high-pressure fuel pump and the injection nozzle into a single component for each individual. The engine was mounted in the rear, pushing millions of Americans from Chicago to Los Angeles. Fleet owners watched closely.
A camshaft, the shaft that controls valve opening and closing, and in this case the injector timing, physically pushed a plunger down inside the unit injector,
blasting fuel into the cylinder with extreme violence and precision. For an American mechanic working in a dimly lit truck stop garage or a fleet if one cylinder started misfiring, the mechanic did not have to remove an entire central injection pump and send it to a specialized rebuild shop. They simply pulled the valve cover, removed the single bad unit injector, dropped a new one in, and sent the truck back on the road before the next shift. However, this system required a very specific ritual. All the unit injectors were linked together by a mechanical control rod known as the fuel rack. Adjusting the rack required patience, skill, and a deep understanding of the engine's geometry. If a mechanic in a rush set the rack incorrectly, the injectors could become stuck wide open.
Because a diesel engine does not have a throttle plate to choke off air, an engine with a stuck rack would accelerate uncontrollably until it destroyed itself.
A terrifying event known as a diesel runaway. Mechanics quickly learned to respect the rack, often keeping a heavy wooden board nearby to slam over the air intake to choke the engine if a runaway started. Once properly adjusted, the engine had a personality completely alien to its four-stroke rivals. A Cummins or Caterpillar four-stroke engine, an engine that completes intake, compression, power, and exhaust strokes across four piston. Drivers were taught to keep the engine RPM low and let the torque pull the load. The two-stroke Detroit demanded the exact opposite. Because it fired on every single downward stroke of the piston, it lacked the heavy, slow-turning inertia of a four-stroke block. To make power, a Detroit had to breathe, and to breathe, it had to spin fast. The red line was the required operating envelope. An old American trucking joke stated that to drive a two-stroke Detroit properly, a driver had to slam their hand in the truck door. You could not lug a Detroit diesel. You had to run it against the governor, shifting gears constantly to keep the engine screaming near maximum RPM.
And the sound was inescapable. Because a two-stroke fires twice as often as a four-stroke, a Series 71
The exhaust note was a high-pitched, frantic howl that could be heard echoing off mountain passes and cutting through the night air on Route 66.
Truck drivers affectionately and sometimes derisively named the engine the Screaming Jimmy. In an American truck stop in 1955, you did not need to look out the window of the diner to know what kind of truck was pulling onto the scales. The sound announced the engine 3 gears away. That sound translated directly to industrial scale.
Throughout the 1950s, the engine moved beyond buses and experimental trucks into mass adoption.
Truck builders like Peterbilt, Kenworth, and Freightliner began offering the Series 71 as a standard highway option.
Euclid placed them into massive earth-moving dump trucks, helping to carve out the new interstate highway system.
Marine dealers installed them in tugboats and commercial fishing vessels, where the engine's ability to run at a continuous, steady RPM made it a legendary marine engine. A power plant operating in a marine environment, typically inboard on commercial vessels. The Redford assembly plant in Michigan. The modular design meant that parts were cheap, interchangeable, and available at nearly any parts counter in North America.
The engine was no longer just an alternative to gasoline. It was the mechanical heartbeat of an expanding nation. The badge had found its believers. The industry had not yet shown the price of running an engine that consumed oil by design.
As the 1950s turned into the 1960s, the American landscape was being physically rewritten by the new interstate highway system. The superhighways allowed commercial trucks to travel faster and farther, but to maintain higher speeds with heavier trailers, General Motors answered not by abandoning their two-stroke design, but by expanding its geometry. In 1957, Detroit Diesel introduced the V-block architecture to the Series 71 family. Instead of arranging the cylinders in a straight line, they built a V8, an 8-cylinder engine with cylinders arranged in 2 banks in a V-shape. The resulting engine, the 8V71, possessed 568 cubic inches of displacement and was soon rated at a high. In the American trucking industry, the 318 Detroit became a mechanical legend. It was the perfect engine for the rising cab-over era. Because federal length regulations at the time restricted the total combined length of a truck and trailer, fleets bought cab-over engine trucks, heavy highway tractors. An 8V71 nestled under the doghouse of a Freightliner White, a Peterbilt 352, or a GMC Astro at a 1960s truck stop on Interstate 80, the auditory dominance of Detroit diesel was absolute.
When a driver started an 8V71, the engine barked to life with an aggressive, rattling idle.
Because the engine had to be kept at high RPMs to make power, drivers rode through complex 10-speed and 13-speed manual transmissions, keeping the engine screaming against the governor. The sound of a Detroit pulling a grade in the middle of the night. A frantic, high-pitched, two-stroke howl echoing. But the glory of Detroit diesel was not just on the highway. The company applied their modular philosophy to new displacement sizes, blanketing American industry with two-stroke power. In 1958, they introduced the Series 53, named for its 53 cubic inches per cylinder. This smaller block was dropped into medium-duty delivery trucks, logging skidders, and military armored personnel carriers. In the agricultural sector, the Oliver Farm Equipment Company bolted the screaming 453 Detroit into their Oliver 1950 tractor,
turning quiet Midwestern farmlands into high-decibel arenas of earth-turning torque.
Later in 1974, Detroit launched the massive Series 92, a larger bore engine designed to push
Margils. This mechanical ubiquity created a massive, self-sustaining service network. The dealers, mechanics, parts.
An entire generation of American mechanics was raised on the rhythm of adjusting Detroit diesel valves and setting the fuel rack. The engines were famously messy. Because of the Roots blower forcing air into the airbox and the constant scavenging process of the two-stroke cycle, mechanics joked that if a Detroit isn't leaking oil, it's out of oil. In the 1960s, this was simply viewed as the accepted cost of durability. Fleet maintenance shops bought heavy oil by the 55-gallon drum. Drivers kept extra gallons in the cab, and nobody worried about a few drops on the pavement because the engine always got the load to the dock. In an America where an engine could decide whether a field was cut, a truck made its delivery, a boat left the dock, it was iron, fuel, labor, heat, sound, repair, and trust. Detroit diesel had captured that trust. By the early 1970s, the company was capturing roughly 30% of the heavy-duty American commercial truck market. Their foundries were pouring iron around the clock. Their interchangeable parts were sitting on the shelf of nearly every heavy-duty parts counter from Los Angeles to Bangor, Maine. Detroit diesel owned the highway. But the company was about to discover that maximum scale was also maximum exposure to a changing world.
The scale of Detroit diesel's empire in the 1970s extended far beyond the asphalt of the interstate highway system.
Because the engine was modular, General Motors simply kept adding cylinders to capture heavier industries. If an 8V71 was enough for a highway truck, the market demanded to know what a larger block could do. Detroit answered with the 12V71, an engine affectionately and sometimes fearfully known by American mechanics as the Buzzin' Dozen. This massive V12 engine became the premier power plant for heavy earth-moving equipment, large industrial pumps, and specialized heavy-haul trucking.
But it was on the water where the larger two-stroke blocks found their most loyal believers.
In the Gulf of Mexico, the offshore oil industry was booming, requiring a fleet of fast, heavy crew boats to run supplies to oil rigs.
A commercial boat captain navigating heavy swells and dangerous docks did not want an engine that took time to spool up.
Because a two-stroke Detroit fires on every downward stroke, it possessed an almost instantaneous throttle response. When a captain threw the throttles forward, a pair of Marine Spec 12V71s or 16V71s, the massive 16-cylinder, the high-pitched scream of twin Detroits pushing a crew boat out of a Louisiana marina became the defining acoustic signature of the American offshore oil boom.
The same fast response characteristic made the engines indispensable in emergency standby power.
When an American hospital lost power during a severe thunderstorm, the backup generator had to come online immediately. A generator engine, an engine used to turn a generator and produce electricity, must reach its operating speed, usually 1800 engines. A four-stroke engine had to overcome its own mechanical inertia to reach that speed. A two-stroke Detroit Series at 92
storing life-saving power with a deafening roar. By the late 1970s, the Redford assembly plant was an industrial fortress.
The foundry poured thousands of tons of iron, The machining lines ran 3 shifts, cutting cylinder bores and facing blocks.
The engine families had expanded into a massive catalog: the Series 53, the Series 71, and the massive Series 92.
General Motors, the largest corporation on Earth, backed the division with unparalleled manufacturing might.
To work on these engines was to belong to a specific American fraternity. An experienced mechanic did not just fix a Detroit, they tuned it by ear, setting the fuel injector timing with a specialized gauge, adjusting the governor, and running the fuel rack required a tactile understanding of the machine. The engines were deeply mechanical, utterly devoid of the computer sensors and software diagnostics that would eventually take over the industry. If a Detroit was running poorly, a mechanic could physically watch the linkage, listen to the exhaust note, and mechanically force the engine back into tune. In 1979, Detroit Diesel was shipping hundreds of thousands of engines globally. They were the heartbeat of Greyhound. They had achieved absolute mechanical saturation. The Screaming Jimmy was not just a successful product, it was an American industrial institution,
trusted implicitly by the fleets that bought them, and the mechanics whose hands were permanently stained with their oil.
The two-stroke Detroit had conquered American logistics through brute force, a sprawling service network, cheap fuel, and a national tolerance for leaking oil.
But the company was about to discover the danger of building a perfect machine for a world that was about to disappear. The first crack in the Detroit diesel empire did not happen inside a factory, and it did not happen because an engine failed on a mountain pass.
It happened quietly, on a paper ledger in an American fleet maintenance office in the fall of 1973.
For decades, the math of American trucking was simple. Diesel fuel was incredibly cheap, and engine durability was paramount.
If an 8V71 consumed a little more fuel than its rivals, or leaked oil onto the pavement, fleet owners accept.
But in 1973, the OPEC oil embargo triggered a massive energy shock. The price of diesel fuel doubled and then tripled.
Overnight, fuel economy, a measure of how far a vehicle can travel on a specific amount of fuel, critical to a trucking company's survival.
This new economic reality exposed the fundamental flaw in the two-stroke design.
Because a Detroit diesel had to be driven against the governor, spinning at high RPMs just to make usable torque, it was inherently thirsty. A driver could not lug a Series 71 up a hill at low engine speeds to save fuel. If they let the RPMs drop, the engine demanded to be fed a constant, heavy stream of diesel just to maintain its power band. Fleet owners, now operating on razor-thin profit margins, started looking closely at their fuel logs.
They began to notice that competitors running four-stroke engines were spending significantly less at the pump. Rival manufacturers recognized the shift and capitalized on it instantly.
Cummins, headquartered in Columbus, Indiana, introduced their Big Cam engine series. The Big Cam was a heavily revised inline cylinders. Cummins instructed drivers to keep the engine speed low, let the torque pull the weight, and save fuel. Caterpillar followed a similar path. For the first time in 30 years, the frantic, high-revving howl of a Detroit diesel no longer sounded like American progress. To a fleet accountant, it sounded like burning money. Detroit Diesel tried to stop the bleeding. In the mid-1970s, General Motors engineers desperately modified the Series 71 and the newer Series 92. The fuel squeezer engines were designed to operate at slightly lower RPMs to improve efficiency. It was a valiant engineering effort. You could change the timing, but you could not change the physics of a roots-blown two-stroke block.
Engines. Then came the second, far more dangerous crack. As the 1970s bled into the 1980s, the environmental
emissions standards, legal rules dictating how much pollution a machine is allowed to exhaust into the atmosphere, were tightening.
For automotive gasoline engines, manufacturers could simply install a catalytic converter, an exhaust device that helps convert harmful gases into less harmful emissions.
But diesel emissions were different. The EPA was targeting oxides of nitrogen, NOx, and diesel particulate matter. This regulatory pressure struck at the very heart of the two-stroke Detroit's mechanical identity. A two-stroke engine breathes by scavenging. The blower forces clean air through ports in the lower cylinder wall. To prevent the pistons and rings from destroying themselves during this high-speed, pressurized process, The cylinder walls require constant, heavy lubrication. By design, a Detroit diesel burns oil. It is baked into the architecture of the block. Furthermore, the airbox and the pressurized chamber surrounding the cylinders constantly accumulated oil, which was then expelled directly onto the ground through specialized drain tubes. A Detroit was not leaking because it was broken. It was leaking because it was functioning exactly as General Motors designed it in 1938. But in the 1980s, a regulatory agency did not care about a 1938 design philosophy. The EPA demanded cleaner exhaust and tighter control over oil consumption. Engineers inside the Redford assembly plant realized that no matter how they adjusted the fuel rack, no matter how precisely they machined the unit injectors,
the service network began to feel the shift. Truck dealers found it harder to convince owner-operators to buy a screaming V8 when a quiet, fuel-efficient...
Mechanics and fleet shops saw the writing on the wall as new truck orders specified Caterpillar power.
American Highway was physically changing. The block was still solid, the casting was still flawless, the unit injector still fired with mechanical perfection. But the engine was no longer judged by whether it could move freight. It was judged by fuel logs and government emission testing.
The machine still worked. The regulatory and economic world around it had already begun to fail. General Motors, the massive corporate parent, was forced to confront an uncomfortable industrial truth. The division that had built its reputation on the two-stroke cycle was bleeding market share by the month.
By the mid-1980s, the Redford assembly plant was no longer running its legendary 3 shifts. Fleet managers, armed with calculators and long-term fuel logs, were bypassing Detroit diesel dealers entirely, opting for the questioners. In a desperate bid to modernize the aging architecture, Detroit Diesel introduced a technological leap in 1985. This was an early electronic engine management system, a computer that calculated and controlled exactly when and how much fuel the unit injector sprayed.
It was a brilliant piece of engineering, and it made the engines more efficient.
But putting a computer on a Series 92 was like putting a digital watch on a steam locomotive.
Electronic injection could not change the physical reality that a scavenged 2-stroke engine inherently consumed its own lubricating oil, and therefore could never... The engineers inside Detroit Diesel knew the era was ending. Quietly, they had been developing a completely new engine. It was an inline 6. It featured an overhead cam, an engine design with the camshaft located above the combustion chambers in the police. It was heavily computerized. Most importantly, it was a 4-stroke. But launching a completely new engine architecture engined. In 1988, a massive shift in corporate consolidation occurred. A major automotive corporation spun off a prominent... Penske walked into a sprawling, aging manufacturing empire that was steeped in 2-stroke pride, but losing money at an unsustainable rate. He brought a ruthless, unsentimental business logic to the manufacturing facility. The new owner understood that the company could not survive on nostalgia.
To save the engine manufacturing division, he had to fundamentally transform the core mechanical identity that had built it.
Under the leader's aggressive guidance, the company put all of its chips on the newly developed 4-stroke engine, releasing it to the commercial market as a specific engine model.
The innovative engine model was an absolute revelation for the trucking industry. It was clean. It was incredibly fuel efficient.
It integrated perfectly with advanced electronic controls. And crucially, it did not leak oil.
As the Series 60 began to capture massive fleet orders from companies like Schneider National and J.B. Hunt, the 8V71 and the 8V92 were no longer the flagship products of the American highway. They became legacy equipment. Dealerships stopped recommending them to owner-operators. Mechanics who had spent their entire lives tuning the mechanical fuel racks found themselves plugging...
By the early 1990s, the EPA emission standards grew so strict that Detroit Diesel officially discontinued the 2-stroke.
The engines were simply banned from being installed in new highway vehicles. They survived for a few more years in specialized marine applications. But the highway empire was dead. The high-pitched, frantic howl that had echoed across the interstate highway system for the sound of American logistics had changed. The era of a driver slamming their hand in the door to get angry enough to drive a screaming Jimmy, the American truck stop was transformed. The puddles of heavy oil on the concrete began to dry up. the stockpiles of 55-gallon drum. A mechanical culture of constant, tactile adjustment was replaced by a culture of sealed sensors and diagnostic codes. The transition was a textbook example of corporate survival. Roger Penske and the Series 60 saved the Detroit diesel name, but the survival of the badge required the execution of the soul. The engine still ran, the orders slowed, the rulebook changed, the parts got harder to find. The world it powered was gone. Roger Penske's ruthless gamble worked. The Series 60 four-stroke engine did not just save dangers. By the late 1990s, the company was profitable, modern, and perfectly aligned with the new era of strict EPA emission standards.
In 2000, this success attracted a massive corporate consolidation. Daimler-Chrysler purchased Detroit Diesel.
Today, the massive Redford assembly plant in Michigan remains open and active. It produces highly advanced,
But the corporate entity that builds those engines shares almost nothing with the GM diesel division of 1938, except the physical address and the name on the building. The brand dilution, the weakening of a brand when the name remains but the original product, factory, or identity changes, was absolute. The survival of the Detroit badge required the complete erasure of its original mechanical soul. Yet the two-stroke block refused to vanish cleanly into the history books. A surprise footnote to the highway ban was the United States military. Because the Department of Defense operates outside standard commercial EPA emissions regulations, the military continued to order replacement Series 53 and Series 71 blocks. Out on the water, the resistance to the four-stroke transition was even stronger. In the commercial marine industry, a boat owner does not easily abandon a trusted power plant. Replacing an aging 12V71 or 16V92 often required cutting open a ship's steel hull to fit a completely new four-stroke architecture. Instead of upgrading, commercial fishermen in Alaska and tugboat captains in the Gulf of Mexico hoarded spare parts, rebuilt their old blocks, and kept the two-stroke screaming. The frantic howl of a Detroit lingered at the docks long after it had faded from the interstate truck stops. Eventually, the highway engines found their way into a sprawling, fiercely dedicated American preservation community. Today, the Screaming Jimmy survives as a cultural artifact. At vintage truck shows across the Midwest, in rural machine sheds, farmers intentionally keep old Oliver tractors running just to hear the 453 cut through the quiet air of a harvest morning. Junkyards and salvage yards still harbor rusted green blocks, picked over by restorers and hot rodders who swap 671 engines into custom rat rods. There are entire YouTube restoration channels and vintage engine forums dedicated entirely to preserving this specific architecture. Older mechanics teach younger enthusiasts the forgotten rituals, how to run the mechanical fuel rack, how to avoid a runaway, and how to tune the unit injectors by ear. This massive cultural afterlife is not merely nostalgia. A running Detroit diesel two-stroke is a physical argument about Today, a modern commercial truck engine is a sealed, software-controlled black box. If an electronic sensor fails on a mountain pass, the driver cannot fix it with a wrench. They must pull over and wait for a technician with a diagnostic laptop. The truck is no longer a purely mechanical object. It is a computer rolling on rubber tires. The old two-stroke Detroit represents the absolute peak of the tactile era. It was an engine built around modularity, where one cylinder's parts fit the rest of the catalog, and where a mechanic could rebuild the entire. It communicated its health through physical vibration, the color of its exhaust smoke, and the pitch of its whine. It required a human being to understand its geometry and to get their hands covered in its heavy oil. America did not stop needing freight moved, fields plowed, or oceans crossed. It simply stopped needing a machine that required a driver